Hi and welcome to Coventry Auto Components. We're using these series of videos to introduce you to new parts to our extensive range that we've been making since 1969. So whenever we talk to customers about cooling problems, I always refer them to fitting a modern sealed type system. To utilise this, on the radiator of the vehicle itself, we take off the standard pressurized cap and we fit a blanker cap. The blanker cap then allows the overflow to be rerouted through a hose, and note this is a heavy duty servo hose because it is going to be under pressure and we do not want it to collapse. This then feeds into this end of the header tank, which has a pickup that drops right down here into the tank, and this holds a couple of litres of water. So when your radiator does spurt some out, and believe me they all do, because you've got a big, heavy, long engine holding a lot of capacity, so as it spurts it out it is caught in here, and then as we load it up with a vacuum cap it's kept under pressure and it is returned back into the system. This is important because otherwise you could lose up to half a pint every time you stop. So this is why modern cars use a sealed system and classic cars have overheating problems, because they lose fluid continually until the system drops. And when the system drops too low, the capillary in the oil and water gauge will also blow. These tanks are beautifully made and they feature a universal type bracket, as you will have to find a custom fitting position depending on the equipment on your vehicle. And as we say, this end takes the feed in, and there is an overflow in the case of an emergency when it has to discharge. That can just be vented to ground. As you can see here, the early XK system uses a much larger, what we call commercial cap, which is 70mm. The later cars, the late 140 and 150, go down to a 60mm, more common type that you probably experience when seeing on your everyday cars. If you do have the opportunity to see any XKs out and about, you will notice an awful lot of owners do run these header tanks and do find places for them, but it just depends on what equipment you've got in your engine bay, left or right hand drive, which reservoir canisters you have around, etc, etc. So you just have to be clever, or you route it through the sidewall and under the wheel arch to a safe place, where of course you can still maintain it and remove the cap. Now this kit is only going to be really effective if you've got a fully efficient system. I did at this point recall that I'd had a situation with one of my own classic cars where, to my memory, there was a good rebuilt radiator in. What I was forgetting, of course, is that I'd had the car for over 20 years, and what may have been new to my mind, in fact, was getting a bit old and decrepit. So I said, let's test that radiator and see how well it flows against a rebuilt one, because that's an interesting thing to do, and we can do that here with a kettle. So here we go. We are reenacting that, and it is a good example of thinking about building the car sensibly, and what may be new to you may not be that new if you've got a good memory. So here we are. It's quite a simple experiment. We've got a catch tray, an old radiator we've taken off the shelf, and we are going to pour some water through it and test the flow rates, and then we're just going to do it with a record one so we can get an idea of how quickly they should flow in this situation, which will relate to being in the car and pressurized, but obviously we're just doing it as an experiment here for our own amusement. This is an old radiator. What we're going to do is pour 1.5 litres of water through, and we're going to measure the time it takes before it comes out of the bottom, and we'll start now. Stop. How many seconds was that? 5.5. So this is a new record radiator, and we'll just do exactly the same thing and measure the time taken for the flow to go through a new core. Go. Stop. Whoa.
I went up and I've seen it move at the bottom.
Yeah.
And that was way faster.
That was 2.65 seconds. And the results are back from the lab, so if there's any doubt in your mind what you've just seen, basically a newly record radiator appears to flow twice as quickly as an old unit that to the eye seemed to flow nicely. So I guess there's the answer. Once again, the test has been proven to be right. So here we have the Coventry Auto Components service exchange rack, and as you can see we also do keep some new stock of aluminium radiators when we can get them, because they do have long lead times since COVID. But we try and offer a service where a customer could come in and exchange a unit to his satisfaction and then leave with it, which is pretty good for 70-year-old car parts. As you may note here, the XK150 does feature an angled extended neck, and this part can get damaged in storage or in transit, so do check once it's fitted that it does actually sit level so you can fill it right to the top, or you just won't get enough water into it. And sadly, as you can see, we do get sent radiators in any condition, and we do our best to save them because they can be expensive to replace. So we do an exchange on a like-to-like basis. The late 140 features a fluted top tank, whereas the early one features a wide heavy tank which then has a smaller fan. The 120 is the same kind of design, so again takes the smaller diameter fan which goes up to about 14-inch max. There's a particular point to note on these original radiator necks that they are in fact a deep neck radiator cap, and you do need a deep necked matching cap to reach the bottom, or it will not pressurize on standard systems. If you look here on the Repro one, that uses a shallow neck. You can see a distinct difference between the two, so make sure you always have the right cap or you're going to have an unsealed system. As you can see from here, aluminium radiators do come bare, but they should really be primed and painted black so they also radiate the heat correctly.